Hello, students, and welcome to our lesson. We have a new topic today. We're going to start learning about the real number system. But first, we will have our do now prompt, and we're going to talk about making a change. And then we'll start with our objective, learning about the real number system, while we answer our essential question: what are the different kinds of real numbers and how are they different? So for today, we're going to answer our do now in our Teams class notebook. Watch the video, and we've got 3 pages to complete. We will answer our exit ticket in our class notebook, and most importantly, we will show the teacher our completed work. For our exit ticket today, we will define whole numbers, integers, rational numbers, and irrational numbers. And then we will go on to homework, where if you haven't finished up your work in class, just finish up. To get full credit, we know, let's get our camera on so we can build that sense of community. A couple of your classes are really starting to do a great job with that. Make sure you respond when your name is called at the beginning, middle, or end of the period. Definitely show me your work at the end of the period, even if it's not done. I am delighted to see whatever you've accomplished because you work so hard. And if for some reason your camera's not working, just send a photo to my email right here. So let's take a look at our do now. Oh, we have an announcement. Let's not forget that. Map testing begins on the 4th and 5th next week. That's Thursday and Friday. And remember, get off to a good start for the third quarter by turning in your work on time. It will help your grade and it will help your understanding of math. You always want to stay on top of math. We've got bright orange today. I love it. And we have a great do now question. So, throughout history, people have spoken up and started movements to bring change. Examples include the civil rights movement, women's issues, animal rights issues, bullying issues, and many, many others. Sometimes change can take a long time. In fact, it can take many years. But why should we work to change things if we can't solve the problem in our own lifetime? So, if it's going to take a long time to get something done, why should we do it? Let's think about that. Well, if something's going to take a long time this year, it's still going to take a long time 10 years from now. But if we start this year, then maybe in 20 years, the people who enjoy what we left will benefit from our hard work and our making change. I'm sure you can think of other reasons why even though it's hard to work on something that you're not going to see come to fruition or come to pass for a long time, it's definitely worth it to work on it anyway, to plant those seeds, to light that fire and get that thing going. So I'd love to hear your thoughts about that, and you can put them right here. So here we have our exit ticket. And then moving on, we're going to talk about the real numbers. Today, we're talking about 4 kinds of real numbers: irrational numbers, rational numbers, integers, and whole numbers. So, an irrational number is one that cannot be expressed as a fraction with integer values in both the numerator and the denominator. Okay, when we write an irrational number as a decimal, so when they're written as decimals, they do not repeat and they do not terminate. And we're going to talk a little bit more about how we know when something is a repeating decimal. Now, rational numbers are a little different. A rational number is one that can be expressed as a fraction with an integer values in both the numerator and the denominator. When rational numbers are written as decimals, they either terminate or they repeat. Now, the integers, we have talked about integers quite a bit. Okay, an integer is a number that is either a whole number or the opposite of a whole number. And integers cannot be fractions or decimals. So the integers are those whole numbers that we generally think of on the number line. Okay, and they include the positive and the negative numbers. Now, finally, let's talk about whole numbers. And a whole number is any non-fractional number, not a fraction, also not a decimal, starting with 0, unless the decimal is 0 to the right of the decimal point. So in other words, the whole numbers are 0, 1, 2, 3, and so forth. Okay, so that's just your brief overview. Let's get some practice, and let's get my pen ready. How about a nice purple for today? So the question is, negative 16.1546472 a rational or an irrational number? Explain. Well, this number goes on, and we know because of those 3 dots to the far left. A number that goes on, does not repeat, does not terminate, is irrational. So this number is irrational because it does not repeat or terminate. Now, sometimes you're going to need to use a calculator to understand what's rational and what's irrational. In number 2, we're asked to circle the rational numbers. So 4.2 is rational. Because it terminates. 8.53 is rational. Now look, there's a bar over top of the 5.3. It's rational because when we have this bar on top of the 5.3 right here, what that means is that 5.3 repeats. So let's look how that would work. If we were to take that bar away, we would have to keep writing 5.3, 5.3, 5.3. So in order to avoid writing 5.3, we put the bar. We don't need the dots. We don't use those. And that means that that number terminates. So it's rational. Now, the square root of 25. Well, remember, the square root of 25 asks the question, what times what, and those have to be the same number, equals 25. Well, we know that 5 times 5 is 25. So therefore, the square root of 25 is 5, and that is a rational number. In fact, that's a whole number. Whole numbers are rational numbers. And negative 2 over 7 is rational because it has whole number numerators and denominators. So it looks like everything is rational. So all are rational. Now, we're asked to estimate the value of the number below to the nearest whole number. So a couple ways I could do this. I know that 13 times 13, I'm just going to write think. I know that 13 times 13 equals 169. I know that 14 times 14 equals 196. And I know that 15 times 15 equals 225. Well, it says nearest whole number. So I would say the nearest whole number to the square root of 200 would be the result of 14 times 14, or would be about 14. So the square root of 200 is somewhere between 14 and 15. The nearest whole number would be 14. Okay, here we're asked to rewrite the given fraction as a decimal. A fraction is a numerator divided by a denominator. So it's 11 divided by 9. So we can actually do this by hand. And I'm lengthening this because we are going to need to do some decimal work. So 9 goes into 11 one time. 1 times 9 is 9. We subtract, and we have 2 left over. Now we put a decimal and a 0. We bring down the 0. 9 goes into 20 2 times because 2 times 9 is 18. When we subtract, we have a 2. We add a 0. 9 goes into 20 2 times. We have to put our decimal there. 9 times 2 is 18. And as we subtract, we keep getting a 2. So this 2 is going to go on and on and on. We'll just keep getting 20. 9 times 2 is 18. Subtract, get 2, bring down a 0. That will just go on and on and on. Therefore, 11 ninths as a decimal can be expressed as 1.2, and it's a repeating 2. You don't have to write it over and over and over. You just put the bar above, and there's the answer. So at this point, we're going to do some error analysis. Okay. First of all, Terence explains 1.3 with the bar over the 3 is irrational because the number does not terminate. Okay, that's wrong. It is rational, okay? And it is rational because even though it doesn't terminate, it does repeat. So it is rational. Okay, let's go on to the next problem. Number 8 is a whole number because, negative 8 is a whole number because it is the opposite of 8. No, whole numbers are not negative. Whole numbers are all positive. Or the only whole number that's neither positive or negative is 0. So whole numbers are positive or 0. Okay, so negative 8 is an integer. All right, let's go on to the next set. We'll identify the error. It says the rational numbers are circled. Well, 1/2 is rational. And the square root of 22, you might want to try using a calculator for this. Square root of 22 is irrational. So this one's irrational. Let's see, 9.12 is rational because it repeats. So that one's okay. Pi is 3.14159, and it goes on and on and on. We had that pi contest last year. People memorized about 60 digits of pi, so that's irrational. But what about the square root of 3 divided by 8? Well, first of all, the square root of 3 is an irrational number, and just dividing it by 8 does not make it rational. So the square root of 3 over 8 is irrational because it will produce a decimal that neither repeats nor terminates. Okay, let's look at Annie's error. Annie converted the given decimal to a fraction. Oh, no, that's not right. If we have 0, well, let me go in the other direction and explain this to you. If we have 4/10, okay, that would equal 4 divided by 10, which would be 0.4 evenly. 4 times 10, 40, okay? No remainder. So 4/10 equals 0.4. Okay, that's not what we have here. Let's take a closer look at this. We have a repeating 4. So the repeating 4 is 0.444, and that just keeps going on. And the only way we can convert a repeating decimal to a fraction is to have 9 as the denominator. So that would be the correct answer. So it would be 0.4 with a repeat. The closest thing would be 4 with a 9 as a denominator. Okay, let's move on to our extra practice. Is the given number rational or irrational? Well, if I take the square root of 32 and I put it in my calculator, this is the kind of number I get. I get 5.6567854249, and that number will go on and on. So because that number goes on and on and on, it is irrational. Okay, number 2. Is the given number rational or irrational? We have a negative 6.146, but look, the 146 repeats, which means this number, the decimal portion, keeps repeating. So if it repeats, then it is rational, because an irrational number does not have a repeating decimal. So let's look at the rational numbers. So 2.3678 has a definite ending or termination, so that is rational. The square root of 40 produces a number 6.324555320, and it keeps going on. So that's irrational. Negative 14 over 6, it is a definite terminating number. It's a rational number. And 9.5 has a decimal that repeats, so that is also rational. So those are the rational numbers. Now, on number 4, we're going to circle the irrational numbers. So the first one is rational. 4 2/3 is rational. The square root of 256 is actually 16. I'm going to write that here. So 16 times 16 equals 256. So that's rational, and I want to just make sure I don't confuse you by circling that. That's also rational. Negative 2.6 has a repeating decimal, so that's rational. Negative 25 over 12 is also rational because it terminates. Now, the square root of 25 is 5, so let's write this over here. The square root of 25 over 12 equals 5 over 12, which is definitely a rational number. However, anything with pi is irrational. So here's our irrational number. Only one in this problem. All right, now we're going to convert some fractions to decimals and decimals to fractions. So when we have, let me just show you this again. If we had 30.32, that would equal 32 over 100. However, this repeating decimal bar changes everything. So that whenever you have repeating decimal bar, we have to go one less than 199. So if we have a 0.3 with a repeating bar above the 3, that would be 3/9. Okay, number 6, 4/9, we want to convert it to a decimal. So we will divide 4 by 9. And we put a decimal in our answer. Have to really line up your work carefully. So I'll divide 40 by 9, and that will go 4 times. 9 times 4 is 36. I'll subtract. I'll have 4 left over. I'll add a 0 and bring it down. Look what's happened. 9 times 4 is 36. I subtract. I have 4 left over. I add a 0. I bring it down. And this could go on and on and on. So subtract 36, and I'm going to have 4 left over. This will go on and on and on. So the correct answer, 0.4 with a line to show that that 4 repeats. Now, for 1/8, we're going to take our 1 and divide it by 8. We're going to do it similarly to problem number 6. Add a decimal, put a 0. So 8 into 10 goes 1 time. 1 times 8 is 8. Subtract, we have a 2. Add a 0, bring it down. 8 goes into 20. 2 times 8 is 16, which we subtract. And now we have a 4. We'll add another 0, bring it down. 8 goes into 45 times even because 8 times 5 is 40. So, we need to put our decimal point in the answer. So 1/8 equals 0, we like that heads up 0, 0.125. And again, we have a repeating 0.6. Now, if we did not have a repeating 0.6, that would equal 6/10. But with the repeating 0.6, it would be 6/9, which we could reduce. We divide both the numerator and denominator by 3. We can reduce that to 2/3. Okay, so let's go back and let's complete our exit ticket with our introduction to rational real numbers. So, whole numbers. A whole number is a number that is any non-fractional number starting with 0. Okay, so that would be 0, 1, 2, 3, and so on. The integers are the numbers that are either the whole numbers or opposite of whole numbers. Okay, no fractions or decimals. And think of a number line. 0, 1, 2, 3, 4, and this goes on to infinity. -1, -2, -3, -4, and that goes on to negative infinity. Now, rational numbers can be expressed as a fraction with integer values in both the numerators and denominators. Okay, also, rational numbers are decimals that terminate or repeat. And finally, irrational numbers cannot be expressed as fractions with integer values in the numerator or denominator. When written as decimals, that they do not repeat or terminate. So we're just getting started with the real number system. We'll be doing more on this. You can look forward to this on Monday and Tuesday as well. But meanwhile, keep thinking about it. Keep practicing all your math. Make sure you get your math facts down, memorized really well. Helps you build that math muscle and be really strong. And as you do that, as always, you know you'll be great.